Homework 2.1, Basics of Functions, Video 5, due Friday, May 22nd, 2020 at 11:59 p.m. This will be the last video in this section. I planned on originally doing 1, 2, 3, 4, 5, 6, 7, 8, maybe 9 videos, but as I was going through them, I realized that I would be repetitive and saying a lot of the same things more than once. So for the sake of your time, and for the sake of my time, which is currently 5:30 p.m., we're going to go ahead and wrap up this section with one video. Extracting information from a graph. This is what I casually call ungraphing, where a graph already exists for a function and we're removing information from it to answer questions. For example, consider this graph, which I did draw a little bit more carefully. I marked off all the X and Y axis tick marks at 2-inch intervals and tried to label some points that were easy to see. And we're going to answer 6 questions, 2 of which we've already answered before. What's the domain and range? 2 of which we haven't answered before. What are the X-intercepts and Y-intercepts? But those are pretty easy and intuitive. And 2 function questions, which kind of pose a problem because I didn't tell you what the function is. I just said y equals some function of x. So let's take it one piece at a time, starting with the domain and range. Now, in a previous video, we talked about pulling the domain and range off of a graph, the domain and range off of a graph, but in both of those instances, we had graphs that started and stopped, as opposed to graphs that go forever, as indicated by the arrows on the bottom left and bottom right pieces of this red graph. So how do you find the domain and range in that case? Well, the same way you did before. The domain are your x values, which on a graph are left and right. So you have to ask yourself, how far left does the graph go, and how far right does the graph go? How far to the left will this graph go? Well, because of this arrow, which means it continues in that direction, this graph will go forever left. And it seems like it's plummeting while it's doing that, but it's going forever to the left. And how far to the right is it going? Well, same story, except to the right. This graph will go forever to the right. So how are we supposed to describe the domain when the graph goes forever in both directions? Well, how far to the right does the number line go? And how far to the left does it go? When a graph goes forever to the left, that means it's approaching negative infinity. To the left. So our domain starts at negative infinity, and guess where it ends? Well, I say ends loosely. This goes forever to the right, which means it's going towards positive infinity in the right direction. So our domain is all real numbers. This graph goes forever in both directions, left and right. For the range, it's the same thing, except it's y values. For the range, it's lowest y to highest y. Let's start with the highest y. Find the highest one on the graph. Here it is. What is its y coordinate? Well, if I drew it accurately, the highest y value on here is 1. But how far down does it go? Well, choose either end because they both go down forever. So let's just choose this one. This goes forever down. Now, relative to the y coordinate is going down positive or negative? Negative. So forever down means it's going towards negative infinity in the y direction. So the range is lowest to highest. The lowest y is negative infinity because it goes forever down, but the highest y value on this graph is 1. And it's part of the range because it's this point's y coordinate, so it's included, which means bracket. So a graph that goes forever in any direction doesn't change how you approach domain and range. It just means that you're going to have to use infinity, negative infinity, or both. Now, we haven't talked about intercepts, but I think the concept is fairly intuitive. An X-intercept is where a graph crosses the x-axis. How many points does this graph cross the x-axis? Here and here. Okay, where on the x-axis? This one's easy, 0. But where's the other X-intercept? Looks like it's at -4. So our two x-intercepts are 0 and -4. Later, we will learn how to locate the x-intercepts from the function as a means for coming up with the graph, but we can also extract them from the graph. And the same thing for the y-intercepts. Where does this graph cross the y-axis? Well, at the origin as well. And at the origin, what does y equal? 0. So pulling intercepts off of a pre-drawn graph is pretty easy. Where do you cross the x-axis? Where do you cross the y-axis? But what might not seem so easy is how to do f of 2 and f of -2. Because normally to evaluate a function using function notation, you substitute your value in for x and then work it out. Problem is, we weren't told what this function equals. F of x equals something. But we have evidence of what happened between the beginning and the end of the graph. Remember, basic graphing strategy is to create ordered pairs and then put them on the graph? Well, we've already got the ordered pairs, so which one do we need? Well, let's think about how this f of 2 would fit if we were making a table. The 2 being the input would represent the x. The output, which is f of 2, would represent the y-coordinate. So we would have a point of the form 2, f of 2. So we know something about the ordered pair we're looking for. Its x-coordinate must be 2. Can we locate a point on this graph whose x-coordinate is 2? Well, here's where 2 is on the x-axis, and there's a point on the graph below it here. This point whose x-coordinate is 2 is 2, -3. So if we compare generically what would happen when we put in 2, f of 2 as its y-coordinate, and grab the evidence of what already happened, but when we put in 2, we get out -3. And remember that in a function, every x has a single y value. So the only way 2 could be paired with f of 2, and 2 be paired with -3, and be a function is if these y-coordinates were equal. In other words, f of 2 is equal to -3 because the point on the graph where the x is 2 has a y of -3. And we can use the same reasoning for f of -2. When we put in -2 into the function, whatever comes out is the y-coordinate, so we just have to locate the point on the graph where the x-coordinate is -2. So go back to -2, look up, there's a point. This point's coordinate is, y-coordinate is 1. So according to this point, when we put -2 into the function, we get out 1. Now, we don't know how the -2 turned into a 1, and we don't know how the 2 turned into a -3, but the evidence from the graph says that's what transpired. So extracting information from a graph is fairly straightforward as long as you understand the relationship between x's and y's in a function. The x is the input, the y is the output, and knowing what you're looking for. Whether it's all the x's for the domain, all the range, all the y's for the range, the certain x's on the x-intercepts or y-intercepts, or specific points based on their x-coordinates that you're given. I am sure that there will be some questions that arise in the homework, so please contact me if you have any questions. But that's the end of this homework video series. Sorry, it's been a long day.